Okay, class. Let us now discuss present value. Okay, which is also a very important concept in the study of interest theory. Now, in simple terms, present value means what is the value of my investment today? Okay, or what is the value of my investment now? So we have our accumulation factor, which is 1 plus I. It accumulates the value of an investment at the beginning of the period to its value at the end of the period. Okay. So we looked at accumulation factor AT. If you remember small AT, where under interest theory is 1 plus IT, and under simple interest is 1 plus IT, and under compound interest is 1 plus I all to the power T. Now, this is the accumulation factor. What takes your investment, what takes your investment to the end and helps us to know the value of investment at the end of the period. We also have the discount factor, which is we use V to represent it. And this is equal to 1 over 1 plus I. It's the inverse of the accumulation factor. Now, the discount factor discounts the value of your investment at the end of a period to its value at the beginning of the period. So you may know the value of an investment at the end of a period. Okay, if that is the case, what is its value today? All right. So we have a discount function. The accumulation function was AT, but the discount function is A inverse T. It's simply 1 over AT. Okay. All right. So on a simple interest, the discount function is 1 over 1 plus IT, but on a compound interest, the discount function is 1 over 1 plus I all raised to the power T, which is equal to V to the power T, because 1 over 1 plus I is equal to V. Okay. So discount function is generally or simply the counter of the accumulation function. Now, accumulating and discounting, as I said, are opposite processes. So the term 1 plus I to the power T is said to be the accumulated value of 1 at the end of period T. Now, the term V to the power T is said to be the present value of 1 to be paid at the end of period T. Okay, so let's look at an example here. Find the amount which must be invested at a rate of simple interest of 9% per annum in order to accumulate 1,000 at the end of 3 years. I would like to illustrate this. So the question is saying, find the amount which must be invested at a rate of simple interest 9%. So we have our I to be equal to 9%. So we want to find the amount which must be invested at a rate of simple interest of 9% per annum in order to accumulate 1,000 at the end of 3 years. We want to get this, okay? At the end of the 3rd year, we want to get 1,000. What should I invest today so that I get 1,000 at the end of the 3rd year? That's a simple question, okay? So the solution is that you use a discount factor, V to the power T, or just a V. And on a simple interest, this is equal to 1 over 1 plus IT. So to know the value today, my present value is equal to 1,000 times 1 over 1 plus 0.09 T3. And that's equal to 787.40. Okay. So you can see this in the notes. All right. Example 3 is saying rework the example above using compound interest instead. So you can try this on your own. We want to look at the effective rates of discounts. The effective rates of discount D is the amount of discount earned during the period to the amount invested at the end of the period. Remember, the effective rates of interest looked at amount of interest earned during the period relative to the amount of interest earned during the period relative to the amount of interest earned to the amount of investment at the beginning of the period. By rate of discount is looking at amount of discount earned during the period in relation to the amount invested at the end of the period, okay? So the phrases amount of interest, amount of discount can be used interchangeably in situations that involve interest rates or discount rates. So the key distinction between the effective rates of interest and the effective rates of discount is summarized as follows. Interest paid at the end of the period on the balance at the beginning of the period. So for interest rates, effective interest rate, the amount of interest is paid at the end of the period, okay, to the investor on the balance at the beginning of the period. But for discounts paid, it is paid at the beginning of the period on the balance at the end of the period. Okay, so that's the distinction between the two. So sometimes when you're going to buy something, they will say discount sales or something, discount sales of 10%. So, or they are going for an investment and it is discounted at 10%. So it means that the value of the investment is, let's say, 4,350. Okay, 4,350. But when you are going to buy the investment, you pay with 4,000. You pay 4,000. So they have discounted this for you. And at the end of the period, you receive your 4,350. So what you are receiving is a discounted value. Okay. It is calculated on the amount at the end of the period. Effective rates of discount over any particular period can be mathematically, or the formula is given as this. So you realize that is the difference in this amount of discounts, okay? The value of the investment at the end of the period minus the value of the investment at the beginning of the period, all divided by the value of the investment at the end of the period. Let's look at compound discount. Now, if we have compound interest, in which case the effective rate of interest is constant, then the effective rate of discount is also constant. So this situation I refer to as compound discount. So we want to look at a relationship between effective rates of interest and then effective rates of discount. Because these are all ways of, these are all interest measures, there's some form of relationship between the two of them, okay? We call it the equivalence relationship or the concept of equivalency. So in simple terms, I is equal to D over 1 minus D. This is the relationship between effective rates of interest and then effective rate of discount, okay? You can do algebra on this to find out how to make D stand alone, and you see how D also relates to I, okay? As I said, you can also make D stand alone, and D is equal to I over 1 plus I. There are other ways you can manipulate these formulas to get other relationships like D equals to IV, D equals to 1 minus V, I minus D equals to ID. So let's look at a few of them as I illustrate them here. So we're talking about relationships here. And we are saying relationship between effective rates of interest and then effective rates of discount. I and then D. And we are saying that I is equal to and D is equal to I over 1 plus I. You can do your algebra to see how this works, okay? Okay. Then we further say that D is equal to IV. Look at this. V is equal to 1 over 1 plus I. So this is equal to I times 1 over 1 plus I, which is equal to I over 1 plus I. So indeed, D is equal to I over 1 plus I. And that's how come it can also be equal to I times 1 over 1 plus I, which is equal to IV. Okay. All right. So you can look at the other relationships. We have D equals to 1 minus V, see how they relate, and then I minus D equals to ID. You can do your algebra on these things, see how they link to the other relationships. So at this point, we have simple discounts being given as 1 minus dt. And then the compound discount is given as 1 minus d all to the power t. Okay. All right. So an example here, we are being asked to rework example 2 and example 3 using simple and compound discount instead of simple and compound interest. So whatever rate was given in those examples was 9%. Instead of using the simple interest accumulation factor, use a simple discount accumulation factor, and then same for this simple compound discount accumulation factor. Okay, so you can try this on your own. All right, let's look at normal rates of interest, nominal rates of interest and discounts. Okay, it's used for rates of interest and discounts in which interest is paid once per measurement period. I would like to end the session here. We'll look at nominal rates of interest and discounts in our next session.